So it's the same fluctuation because it's based on the previous demand. Total loss, that's the one that I was talking about. In 1996, it was 22.5% from the generating plant to the substation in your city, like any substation that you see here in Miami. We're not talking about the distribution loss. We're talking about that part only. So that's a lot. And right now it's going back to 30. That's something that you cannot work with that. Only a government like that can work. FPNL would go broke if they do that. I mean, that's impossible. Number of blackout days. Look at 1994. That was the middle of the crisis. 350. Now start working down. And then when the renewal of this plant started to start, it stabilized a little bit, but now it's starting going up again. That's numbers of days without electricity. I don't mean in entire Cuba, in any town, in any place. That's what that graph means. This is like an average. How many blackouts today? 3, 4, 5. That's what that means. That is not seen in many countries either. Available percentage power. That should be, in a typical situation, should be around 85–90%. In here, the maximum is 74%, the maximum. And that happens in the year 2006, really. Now it's going back again, down. That means the efficiency by which those plants are working, and that's incredible. If you look at the vertical axis there, that's thousands of hours. Thousands of hours. And that's the total time of system interruptions. And that's also the beginning of the, you see, the real crisis is around 1999, and you see the large number there. Then they reach like a plateau, where that's the time where they start modernizing all these companies, and then back up again, because it doesn't work. The modernization doesn't work. What are they trying to modernize? Use natural gas instead of fuel oil. Use better fuel oil, and things like that. That's, so the decision to make in Cuba in the future, to me, is, are they going to use fuel or are they going to use gas? And I agree with Buck that it has to be gas. Natural gas, at least, is going to be with us for the next 30 years. Nuclear, 100% also, but not with this government, of course. Once you get a stable government, nuclear and natural gas. And the other methods are just to help the systems at the time of the peak hours, to help the cost of the system. So I made a series of graphs that if you need the data in detail, I can send it to you by email, because I don't want to bother you with all of this. In the third paragraph, in the second paragraph, I said 3 of the gas conversion projects benefit from the construction of a liquefied gas import infrastructure, which is a keystone of $400 million in a regasification plant at the port of Cienfuegos. That's there, and that's helping, but that's only part of it. Also, there are other companies. A Swiss company that is doing something with the Antonio Guiterres plant, and is going to work in the same area. So that's more about the power plants to gas that they are doing. They are working on this, but it takes time, it takes money, and they don't want to use it. That's another interesting graph. Energy not served. That's in gigahertz. Megahertz is like a million. Gigahertz is 1,000 a million. And look at that graph. That's the energy not served. And again, it shows the crisis in the 90s, the bottom where they started to do something and then backing up again to be worse. Again, more about what Cuba should do about converting to gas. Future investment in Cuba power generation. I'm going to show you some numbers in here. It's very difficult to digest in a situation like this, so I'm just going to go fast. But it's based on the three type of plant that I'm showing there. The one on the top is a new combined cycle unit, which they call G gas turbines, with a heat recovery steam generator. Those in FNL know what that is. That's the future. That's what they're using. The other is a little bit cheaper, and the third one is the less expensive. So I made a slide that gives you the higher cost and the lower capital cost based on whatever the selection is done. But any one of those, higher or low, is high. It's looking like our deficit. If you look at those numbers, is that the United States deficit? No, it's not, but now, Cuba had to add by last year this amount of power there, but they didn't. And that means that they are 500 megawatts behind of what they should be. The plan since 1908 were by 1912 we're going to have 500 more megawatts. They did not. They didn't do anything about that. And that's what I'm trying to explain in that graph. So if we consider that, the amount of money increases that you need in order to avoid having the blackouts. What happened? Okay. We are getting to the end now. The present installed capacity. Consider the 7 main thermoelectric plant is, in round number, 3,000 megawatts. The Grupo Electrógeno is about 1,500, and the Energas 400. So the total installed capacity is 4,900 megawatts. But that's theoretically. Those plants are working at 65%, 60% efficiency. So if you multiply 0.65 by that, that's the installed capacity. And I'm talking about the installed capacity, not the losses. So that's why you have, yes?
What kind of fuel oil do they get from Venezuela? Is it number 2, number 6?
Number 6.
Or is it just JP5?
Number 6, but it's lousy. It's the oil from Venezuela is as bad as the oil from Cuba. And there are very few companies in this world that can refine that. That's what they're trying to do in this enforcement.
It's so inefficient.
Yes, it is. It is. The structure of the generation is, as I'm giving you there, and I'm also mentioning there, as of 2012, the oil consumption, what it was, the domestic production, the imported oil from Venezuela, about 105,000 barrels per day. But the 101,000 barrels per day that they use from Venezuela is not for use in Cuba. They sell it. And the plant that they have in Cienfuegos sell a lot of this oil to the Caribbean island. And you can, if you go to one of them on a cruise and go around, you can see, thank you, Cuba, Venezuela, for the whatever. They don't use it for the Cuban people. They are getting dollars out of that. But that's the number of barrels per day that they are being given. Now I'm giving you there the Cuba installed capacity, the real one, and the demand. If you see the short difference in here, that's why the blackouts. You cannot have that small difference between what you can provide and what they are demanding from you, because if one of those units go down, if one of those units doesn't work well, if the demand increases by any chance, that's the problem. Now, the total installed capacity by type: oil is still a lot, Energas, and the Grupo Electrono. The consumption structure: how much is used in residential, in commercial, industrial. If you look at this, in previous years, this would have been here. And look at that. That's why there's no food in Cuba. There's no processing plants for food. And that's a big problem. So that's the conclusion. And of course, I perceive that in the near future, or in the future, I don't know how near, but in the future, once these two guys died and that disappears and Cuba becomes a free country, if he ever dies, I have my doubts now, then there is a lot of help that we can get from the United States, private companies, I mean, not the government, private companies to invest in Cuba. Thank you.